Okay, so let's say we want to integrate this, okay, plus this. What we need to do is, first of all, understand that 2 over 5 is just a constant, a number, alright? And the x plus 2 whole thing square, right? I actually need to bring it up so that it's in the form a big X to the power of n, where n is minus 2. Okay, then I can integrate. Meaning to say I can get this constant, just leave it. So power plus 1, that would be this, right? Then divided by the new power, that's minus 1. Then you differentiate the fruit, get 1. Okay, and then you simplify here, which will give you 2. You just press calculator, you will get 2 over 5, then this will be x plus 2. So this is what you need to present as your final answer for this particular part here. Okay, so this is a so-called simplest form already lah. So take note, this doggy, right, the constant, leave it one side, nothing to do with you. Okay, then you work with the algebra. Okay, power plus 1 divided by new power, differentiate this, and then you will get this answer. Okay, what if I have something like that? Sorry. If I have something like that, right, this is a constant, a, then x, big X to the power of n, right? When I plus 1 to the power, I'll get 0. Divided by 0 is not defined. So for such cases, it's the ln case. Ln case. So how do we solve ln? How do we integrate this? You have to use ln, but don't, leave this constant alone. Okay, then this, okay, which is not able to be integrated using ax to the power n form, right, will become ln form. So as you were asking just now, is it just take the denominator? Yes, that's the reason why we take the denominator. Okay, but we have to differentiate this and divide by it. Okay, later I'll show you why like that. Okay, so the final result will be 3 of this, put bracket, then it's not confusing. Then the denominator will be 10. If you're not sure, then you just take 3 over 2 divided by 5, you get 3 over 10 lah. That's all. But you must remember to plus C. Very important to plus C. Okay, now why is it like that? Why is it a ln thing? Now the reason actually is, when you learn differentiation last time, you remember when I differentiate ln, okay, and let's say plus a constant C, this whole thing I'm going to differentiate. If I were okay, when I differentiate a number times that, then what would I be getting? I will be getting this number, just leave it. Differentiate this is 1 over this whole thing. Correct? 1 over this whole thing. So I can put a 1 here lah. Okay, then I have to differentiate the fruit, right? Then multiply by the fruit, right? So can you see, ultimately, I'm doing the reverse of this. Okay, I will get, just to show you that final answer is just originally what we have here. Okay, so that you're convinced, this is this, right? Okay, but you can see that, you can see that I multiply here, that's why I divide here, correct? Then I actually, when I differentiate ln, I get this fraction, right? So when I integrate this fraction here with this power 1, I'll get ln. So that's the reason why. Okay, so if you're not sure, you just after integrating, you differentiate, you should get back the original. Okay, so I hope this is clear. I just quickly do, so I don't really know whether I've answered your question. So you just, if you know already, you can turn off lah. But if you don't know, right, then this 2 is my doggy, my constant, right? Leave it as it is. Then this, once you see power 1, holding power 1, you know when you bring up, it's going to be power 0. Oh, then you cannot divide by 0, right? So this is a ln case. Okay, but you must remember to always differentiate this and then divide by this. So it's minus 2 over 3 this plus c. Okay, again this is the doggy, the constant. Then again this is a ln case. Differentiate this, you get 4. So ultimately you will get just 1 over 5 ln 4x plus 3. Okay, and this one 7 over 3 ln 2x minus 5. Then you differentiate these, you get 2. So you get 7 over 6 plus c, plus c, plus c. Okay, then 2x minus 5 plus c. Okay, so that is all. Do not, okay, I don't know whether you are asking about this. Do not go and expand this. You expand this, then you integrate, right? There will be mistakes because your answer will not be the simplest form. Okay, so you do like what I do, and that will be the correct answer. Okay.